Welcome to Advanced Broadcast Technologies. I'm Lidia Paulinska, and we will be speaking on technologies for the rapidly changing world of content broadcast and content distribution. Historically, broadcast has been the term used for over-the-air distribution of television and radio. Today, the term covers not only free over-the-air technology, but content delivery to mobile devices, cinemas, gaming platforms, cable, satellite, internet, streaming, over-the-top and on-demand methods. Today's broadcast environment includes not only distribution but content creation for the cinema, TV, gaming, web, internet-only channel, advertising, and music. In the past, the task was exclusive for professionals, but with the lower cost of computers, high-quality cameras and microphones, and emerging technologies such as drones, consumers, prosumers, and professionals can all participate. To bring the most relevant and cutting-edge technologies to the viewers, we are working with SMPTE, the Society of Motion Picture and Television Engineers, and the IEEE Broadcast Technology Society. The show is being presented to a studio audience and both broadcast and stream live from the Comcast studio at Chabot College in Hayward. Let me introduce my co-host, Pallab Chatterjee, who will be presenting the topic and the speaker for the show tonight. And please enjoy the show.
Thank you, Lydia. Tonight's show is called The Shifting Structure of Media Storage and is being presented by Dave Fredrick of Quantum Corporation. In today's demanding workflow-based storage use cases, it's extremely difficult to satisfy performance requirements, including storage that can satisfy performance requirements, shared user access, while retaining data at the lowest possible cost. No single type of storage can support the performance requirements of primary storage and the low cost of long-term data retention. Dave will discuss the benefits of tiered storage environments to maximize performance, shared access, and data retention simultaneously, without sacrificing data visibility or over-provisioning of the storage. Today's speaker, Dave Fredrick, is a Senior Director of Media and Entertainment for Quantum Corporation. For the last 30 years, Dave is focused on leveraging technology to improve media production and delivery. Since joining Quantum in 2014, he has been working to bring the benefits of multi-tiered, high-performance shared storage to use cases ranging from entertainment, corporate video, imaging, video surveillance, and more. Dave's approach: infrastructure is important, but it should never come between the user and their applications. We'll take questions from the studio audience and from the internet at the end of the presentation. I'm pleased to introduce our guest speaker for tonight's show, Dave Fredrick, to the podium.
So let me take you through some ideas about storage strategies for media. And I promise we're not going to make this a big product pitch. I know that for organizations like this, you're looking for information on concepts. But I assure you that we could satisfy any of the requirements that you see that might fit your installation. So don't hesitate to contact us if you see something you like. One of the problems with storage is that not every type of storage is right for the type of data that you're dealing with. At Quantum, we tend to deal with very large data problems. We focus on markets like video production, surveillance and security, and also technical markets like genomics, geospatial imaging, oil and gas exploration. These are all situations where there's huge amounts of data, and it requires high-speed ingest, accurate capture of information, retention of data for a long time, and in many cases, a lot of people accessing that information. So when you look at these requirements of how am I going to satisfy incoming data coming in at a high rate that I need to protect, sharing a lot of that information in a collaborative environment, and also retaining that data for long periods of time, what you end up with is a situation where you've got these three diametrically opposed goals in mind. One is you want to provide the highest possible performance for your users, and also so that they get the best use out of their equipment and also out of their time. You also want to provide a large degree of shared access to lots of different people. And that in and of itself is another an added performance problem, but it's also a connectivity problem. And finally, you need to be able to hang on to data and not pay an exorbitant amount of money to store that on a long-term basis. You can't throw it away, you can't lose it, but you can't afford to store it on the most expensive high-performance disk. So that's the conundrum, is how can you satisfy all these different aspects of a workflow while always keeping data in the right place at the right time? And why is video such a problem? Why is it such a driver of storage? As you see, as we've moved from standard definition to high definition, from high definition now we're making the transition into 4K. On this diagram, for example, these dots represent relative sizes, conceptual sizes, of 1 hour of video at various formats. The green one is 1080 progressive 60 frame ProRes. Okay, that's the green one at the top. And as we go around the edge, it goes successively down. The one in the middle is 4K RAW. So is the movie production 4K format, and that's 741 gigabytes per hour, right? So this is 1 hour of video. Just to give you an idea of where we're headed, this is 1 hour of 8K. So moving from 4K to 8K is a good deal more than double the requirement, double the storage capacity requirement. So as the technology moves from one format to the next, keep that in mind, that what's happening is, even in 4K, you can go down to Best Buy, you can buy a 4K camera. You don't have to spend that much money. But when you're using 4K equipment, you have to think of the impact on the infrastructure all the way down the line, because it's going to have an impact on how much storage does it take up, how quickly can you move those signals around on a network that might be 1 gigabit or 10 gigabit, and how are we going to share that information among multiple people, because getting that across a network is a demanding task. Right? So video is driving storage to achieve new levels of performance and access, but also retention. And what's happening is that the transitions between these different phases in technology have been getting closer and closer together. Right? The pace of change in video broadcast and video production isn't just constant, it's constantly accelerating. And so for that reason, it's important to have a platform that allows you to keep up with that. So what we'll be talking about today is how can you have a platform that satisfies these workflow needs and also allows you to keep pace with the rapid change in technology. So the first tier of storage that I'm going to talk about, and we'll be talking about multiple tiers, the first tier is primary storage. And this is what almost everybody starts with. Even if you have a small studio, you're going to get a primary storage array. You're going to connect that to an editing system. And now all of a sudden you don't have to render your transitions. You don't have to copy things on and off of a hard drive locally. You can work remotely. And things get a lot easier until it fills up, or until you have to share that content with someone else, or until you have multiple editing systems starting to talk to that storage. So this primary storage has a tendency to grow, and as your facility grows, and the more you use it, the more important it becomes, because it's got all your stuff on it, right? But the characteristics of primary storage, it's usually the fastest performing disks in your facility. It provides access to multiple users over high-speed connectivity at the same time. And you can add many times primary storage. In our case, we have a number of different connection methods, including fiber channel SAN, Ethernet-based NAS, InfiniBand for those clients that need that. But and to date, this kind of system is really the only way you can reliably edit 4K video in an uncompressed format and be able to share that content and work smoothly. The problem with primary storage is it tends to be a little expensive, and in relation to other storage types. It's still the only thing that'll get the job done, so you're paying for it, but you don't want to have more primary storage around than you need. And you certainly don't want old content sitting there taking up space, because that's just costing you money. That's just like paying extra rent just because you like your landlord. Okay? So if you look at the characteristics of primary storage, performance is top-notch, access is top-notch, cost, it's not going to be the most inexpensive storage that you'll buy. In fact, it probably will be the most expensive storage you buy for your facility. For longevity, there's a certain amount of longevity that's built into RAID arrays and to disk drives, and those are going to last a generation of drives or two, but eventually you're going to have to change out from one generation of disk drives to another just to take advantage of the lower cost basis of new disk drives and also higher capacities. So the cost per gigabyte or cost per terabyte will go down, and also the performance will go up. So there's a sort of natural technology refresh that happens with primary storage. Also resilience. RAID 6 is great for managing failures on disk drives, and even 2 failures at a time can be tolerated. Remember, the only difference between a disk drive that's failed and a disk drive that hasn't failed is time, right? All disk drives fail eventually. They're mechanical devices and they wear out. So that's why we build systems to be resilient. Okay, let's go on and talk about private cloud. Private cloud is an interesting concept. Many of you know cloud storage from your use of things like Box or Dropbox or Amazon, right? That's cloud storage. They use, behind that cloud storage, typically you'll find a function called object storage. And object storage is a way of storing data on a set of disks that does not require a file system. Each object contains the data within that object and all the information about that object that tells you what's in it, when it was created, maybe what camera was used to shoot it, who was the camera person, what's the script that goes along with that, maybe the receipt for the catering bill for that project. All of that type of information can go into an object. And then that gets stored on a set of disks that are, I would say, loosely arranged and kept in check by an overarching management system that keeps track of where all the data is. So when we talk about private cloud, what we're talking about is an object storage system for your facility. And these can be amazingly cost effective. And they can start fairly small. You can start as low as 20 or 30 terabytes for an object storage system that'll be completely resilient and allow you to grow to whatever size that you want to add. So it delivers a higher resiliency than RAID in that it uses something called erasure coding, or more specifically, fountain erasure coding. You can look that up on Google and it will explain in more mathematical terms than I'm qualified to talk about how fountain erasure coding works. So take a look at that. But this provides it with a way for every node in the system to know when a drive has either lost data or failed entirely, and be able to ask all the other nodes in the system for replicas of that data, and it can calculate that and put back together that data and restore it somewhere else in the machine. So it's self-healing. You don't have to replace drives the way you do in RAID. You can wait till the end of the month and gather up the failed drives and replace them all at once if you want. You can change out from one drive to another type within a system without having to replace all the drives in the machine. And it leverages a new kind of accessibility in terms of, because it doesn't have a file system, you don't have to talk to it with a particular type of client. You can talk to it with any type of client that can talk over HTTP. So you could reach it with your Mac, with your PC, with your Linux box, with your iPad tablet, with your phone. Whatever device can speak HTTP can access content in a cloud, in an object store. And this makes it great for content repositories and content delivery systems where you want to put content and have it sit there and yet be instantly accessible by anyone who needs it and can be delivered anywhere that can be reached by a web browser. So let's take a look at how private cloud stacks up. So when you compare it to primary storage, private cloud has a lower performance. It's not going to get as fast because it doesn't aggregate all the disks to perform a single task the way primary performance does. Primary storage uses all those spindles, hundreds and hundreds of spindles, to gather the performance of all those drives into a single task to be able to do things like 4K video editing. So private cloud doesn't aggregate that performance. You're getting the performance of any given set of drives, a small set of drives at a time. So it's a little lower. But in terms of access, just as accessible, just as fast to get that first byte back and beginning to get files. Cost is better than primary storage. It still uses disks, but it uses a lower grade of disks. And those can save you money as you start to build up a system that might encompass hundreds or thousands of disks by the time you get up to a system that's supporting a large amount of storage. Where a place where object storage really excels is in longevity. Because of the self-healing capability, the ability to sense when files are either broken or drives have been lost or node has gone down, the ability to heal itself, and then also to accommodate new technologies of disk drives without having to bring the whole system down or replace entire nodes of storage, makes the data extremely long-lived. In fact, the data in an object store can span multiple generations of hardware without ever being taken offline. We can migrate an entire object store from one type of disk to another type of disk simply by pulling nodes out and letting the content fail, and then putting a new node in with new storage and having it fill that back up automatically. So it's really quite an elegant system for a content repository, or it can be used for what we call extended online, which is a place where you might not be doing full multi-stream editing, but for jobs like rendering or for quality control or other types of video analysis processes, it's a good place for processes that are still want to go quickly, but don't have that demanding real-time feedback that a user would want. So in some cases, those are faster than real-time. Other cases, they're slower, but that's a great place to do that kind of work. Resilience, object storage is very resilient, but ultimately, unless you have a plan for disaster recovery, it is a machine that's in a building, and if something happens to that building, that machine is going to go down with it. So object stores can be set up in a mode where you could have multiple object stores that synchronize with one another, so you could create a disaster recovery operation. But that's part of the resilience story. Now, for those of you who are as old as I am and come from the broadcast space, when a tape library meant a place that you would be sent to if you had made a mistake somewhere in the facility, and they'd send you to the tape library to go catalog the tapes in the library. And it was the worst place that you could ever go, because it was just nothing but a bunch of tapes that people had stuck in there, maybe with a label, maybe with a Post-it note, or they scrawled their initial or something on the cassette, and it was all analog, and you had to go through it linearly. Data tape is something completely different. Okay? Think about a hard drive that costs 1/10 the price of hard drives, can be read just as fast as a hard drive, 300 megabytes per second. It takes a little longer to get to the first byte because it's got a spool to that spot, or it might have to be loaded into a robot. But you can have hundreds of these online for the price of a very small disk array. And you can store data, like I said, for 1/10 the cost of keeping it on disk. The key to making tape usable is making the data in tape visible to the users and making it accessible without having them to have to go into a closet and pick up a tape and put it in a drive. So the machines that you see here on the screen are automated tape libraries. They have a robot in them that mounts one of the tapes that it has in it. The small one holds 40, the large one holds 80, and we have tape, and there are tape drives that can hold enough tapes to create a library of over 192 petabytes. So 192,000 terabytes, right? All in one system and all accessible without touching a single tape. You just double click on the file you want. If it's in the library will go find that tape, mount it in a drive, spin it up, and give you the data. And maybe you waited an extra 5 or 6 seconds to get it, but it's there and it wasn't taking up primary disk space, which is like free storage. So think about that. Every time you can get a file off of primary storage and get it onto object storage or tape, you're getting free primary storage back. And that's where the rubber hits the road. So for tape, when you look at this, you've got performance is not as good, but it's not that bad. And that's the thing to remember. When somebody talks to you about a data tape system, don't worry about performance. You're going to be fine with that. Access takes longer than disk, to be sure. The latency to the first byte on tape can be seconds, but once it starts reading, you'll get that file as quickly as you would off of a hard drive. Cost is the best in the entire portfolio of data storage that you could get, and the cartridges are about $100 each for 6 terabytes, so 6,000 gigabytes for $100, and you can buy as many of those as you like. And if you run out of space in your library, you can, if you want to, put them on the shelf. Tape libraries include a barcode system, so you can track them with barcodes, and you can find the ones you want when you ask for a file. And finally, resilience. Tape is among the most resilient type of medium. It can last for 20 or 30 years. And good tape systems, I'm not going to tell you which ones are good, but good tape systems include functions that test the tape every time it looks at it to make sure that the data on there is correct. And you can always take tapes and you can store them off-site in a secure location if you really have some very important content, maybe some legacy material or some archival footage that you're trying to keep safe. So in terms of resilience, it's really great. Okay, now there's so much talk about the cloud, and I'm sure that some of you have experimented with using the cloud. You might have even tried to do some media production by using the cloud as a place to put stuff. To be honest with you, the cloud has a place in media production. It's just not everywhere. And the last thing you would want to do is transfer all of your dailies up to the cloud and then point to that cloud and start trying to do an edit session, because it's just not built for that kind of transfer, that kind of access. It's good for storing content that needs to be kept off-site for a long time. It's good for storing content on other people's hardware. You don't have to have administration costs to manage those machines or that data. And so that allows you to save some money there if you want to. But it's not going to be good for works in progress. And you're not going to be able to ingest directly to it. You'll have to copy files up after their ingest, those kinds of workflows. So keep that in mind. In this case, what we show here is that on ingest, let's say you're doing a live shoot, well, bringing those files in and immediately putting copies in the cloud of the raw footage is a really good idea and a good way to work. If you ever lose something, if a file gets damaged or corrupted, you can always go back to the cloud and get a copy of that original material. So using it to store dailies or on-set shoots are really excellent. In terms of delivery, it works like object storage. So it's really easy for people to get things from the cloud using a simple web browser access. So you can deliver content to your constituents or your audiences who you want to provide that to, or to content delivery networks like YouTube or Akamai or somebody like that. And for archiving and vaulting, and what I mean by vaulting is deep cold storage, archive is available off-site storage, then the cloud is a good choice, provided that you're using it in a way that's commensurate with your budget and your workflow. And that's the important thing about cloud, is that technically the performance of cloud isn't great, right? You can't use it in real time. You've got to use it as a file repository. But access is pretty good. You can get to it from anywhere. You can get to things fairly quickly. You can begin a download very quickly, and that starts to come down. So latency-wise, it's got really good latency. But in terms of pulling files down, it's obviously dependent on your bandwidth to the internet, or to, for example, Amazon. If you have a direct connection to Amazon, that's available, but that all costs money. And that's where the cost column comes in. You notice that this is the only box that has 2 colors of circles in it. So the cost is for archiving or vaulting something, for just putting it there and leaving it there, it's not that bad. But if you ever like want to read a horror story, it's coming up on Halloween pretty soon, get yourself a copy of the Amazon Vault storage pricing structure, and it'll scare you to death. Because there are times when you could pull content down and it could cost you as little as nothing if you're willing to wait for 1 month to pull a file down over the course of a month, a little bit at a time. But if you want that same file in 4 hours, it could cost you thousands of dollars to pull that file down. Same file, just a different pace of recovery. So every cloud service, and I don't mean to pick on Amazon, everybody has their rules, but every cloud service has rules about how quickly you can get things, how quickly you can pull them down, and how much it costs to retrieve your files. Most of them are you can upload for free. They'll let you upload all you want, because then you're going to be charged for what you store there on a monthly basis and then what you pull down on a bandwidth basis. So cost is variable, and you have to be aware of that. In terms of longevity, they're responsible to keep your files. You don't have to care what they keep it on. As they change out their hardware to meet demand, your files are going to go right along with that. So you don't have to worry about longevity. Likewise with resilience. You've put your data in somebody else's hands to take care of, and part of the agreement is I'm paying you to take care of my files. Take care of my files no matter what happens. So they replicate files all the time across many different data centers. So if something happens, your file is still going to be accessible. So from a resilience standpoint, that's really important. So when you look at all of these tiers put together in some combination, and not every deployment has all 4 of the different types of storage. Many cases we'll see companies that are working with primary storage and tape alone. And that works great for them. They can automate the movement of those files to and from the tape. They can still have access to them. It frees up primary storage. They can get their work done and then move things off to tape. And it's a really nice environment. It fits their workflow. But the idea is that we want to have choices that fit our workflow. And choosing the right tier of storage for the data to be in the right place at the right time at the right cost is part of the design of an intelligent storage environment. And ultimately, it's going to make your workflow smoother. It's going to make it more cost effective. It'll make it more predictable. And you'll have the opportunity to make decisions about technology in a very different way. You won't have to do these forklift upgrades when all of a sudden your primary storage is full. You don't want to buy more of the same storage because it's now 2 years ago since you bought some and you want to get something new. Most people would just say, oh, let's just buy another storage array and put it next to it, and we'll run it as a second array. And now you've just added complexity to your workflow instead of improving it. So by having a method to manage content across these tiers, you can actually plan for these changes that we talked about earlier, which are coming faster and faster. So turn that pressure of technological change to your advantage and be able to use it to anticipate these situations and plan for the change rather than react to it. This diagram is intended to show the different stages of the workflow and how the different types of storage can cover these different stages. So primary storage for ingest and work in progress. You have the lattice object storage for nearline archive, and then tape, LTFS, and LTO for long-term vaulting. There's an important attribute here, this big bar right across the top that says unified access and namespace. That's a really important quality of a unified storage environment. It allows you to access content smoothly from one type of device to another, regardless of what computer system you're using. And that's huge, because if you had to connect directly to a tape drive with your Mac, or direct to a disk drive to edit, or direct to an object storage, you'd have to support 3 different formats, and you'd have to have 3 different connections from your computer in order to do that. And so the complexity of operating that way, unless you're a one-guy shop, is probably going to be too much for most facilities. So having a single namespace where every client system, every computer can talk to all of these devices completely smoothly and through the user interface that they're used to using, the Mac Finder, Windows Explorer, open the application and pull down the file open command, and there's 50 terabytes of storage waiting for you to pull some files from. That's a really great environment in which to work, and people they're just there to be productive and get their work done, and they quit fighting over storage. They quit worrying about where's my file. All of that goes away. When you extend this geographically, if you're in a situation where you have multiple offices in multiple areas, you need to be able to communicate between those locations and move content around. So each of the environment you just saw on the previous slide might exist in multiple locations for a given organization. And we want to be able to synchronize content across those. So this will typically happen through the object storage portal tier. So object storage can synchronize content across geographies, and it gives you an efficient way of moving content around and matching the style. So this is a very rough, high-level overview of what a large facility might be looking at from a workflow. But having the production storage, object storage, and tape storage, all providing these different connections for different purposes. And by the way, in this case, this entire facility is being managed by a media asset management program. So MAM systems are great at talking to storage, finding a file, moving it from one place to another. So what we do is we work with all the MAMs, and they write to our storage environment, and we let them manage the movement of content to and from these tiers. So that way, when they know that there's a program that's going to be edited or broadcast or something along those lines, they can move the content into the right tier of storage for that in anticipation of it being needed. Or if multiple people are working on the same project, it can manage all of that work into a single project and maintain the file structure and folder structure that makes it possible for everybody to find what they're looking for. So this is an example of a relatively, it's kind of a simplified view of a complex environment, but it gives you an idea of what happens when we get to a larger set. So this is my in conclusion slide. So thank you very much for your time. But I did want to talk about the importance of workflow storage. What we do in media production, it has the word production in it for a reason. We're factories. We're content factories. And if we can come up with a regular and repeatable and efficient way of producing content, it improves the quality of the product, it reduces the cost of producing that product, and it gives us a more reliable, repeatable way of doing it. And so a workflow is really important to define in terms of how will content come into the facility, how will it be managed, how will it be named, how will it be organized by people, who will work on it and when, and who has the right to look at it and when, and how will it move between the tiers to maximize the use of storage and the cost of storage. So if you ever find yourself in the position of setting up a facility, the first thing you should do is ask, what's our workflow? What is the workflow we want to define? And this has been done many times in many facilities, so it's not like it's not secret knowledge. I mean, there's lots of people who know how to do this, right? You can either rely on finding the information yourselves, or you can hire professionals, system integrators, resellers, have a ton of workflow knowledge, and also consultants that can come in and talk about how best to set up a workflow for your particular type of work. So that's the important thing. So by using workflow storage, you can solve this opposing forces of performance, access, and cost. And that's really the goal of having a tiered storage environment where data moves visibly and accessibly, but moves between tiers, is to solve for that problem. And keeping the right data in the right place at the right time, that's really key. Okay? So with that, I'm going to ask Paula to come back up maybe, or to present some questions. So I'm looking for a little help here, Paul. Thanks.
Thank you, Dave. That was an excellent presentation.
Cheers.
For going through. We got some questions in from the internet before for going through, because we talked to some folks about the talk you were doing. In the opening slide, you listed as one of the large areas, there's technical applications. What new technical marketplaces do you think can benefit from using media storage as opposed to traditional IT-based storage solutions?
Well, so first of all, there really isn't a difference between media storage and IT storage. It's just how you put it together and what you use it for, right? So we use IT storage. We just put it together in a different way that optimizes for performance and access and ingest and those types of things. But in terms of technical workflows, we do see some new areas, particularly around places where there's a lot of data acquisition. So one of the areas that we've started to address is network forensics. Don't know if you're familiar with this, but this is the act of capturing every bit that goes through every firewall in an organization and storing it. And in the case of a hack, you can roll back time and you can go and look at when you were hacked and what that data looked like in every particular location. It takes a lot of performance to capture that information, and it takes a lot of ingest power to capture it all without losing a bit. So that's one. Another area that we see a lot of uptake for high performance storage is autonomous driving. Autonomous driving is the development of self-driving cars requires hundreds of sensors all operating at peak performance, sending data to a receiver at all times so they can analyze what the car is doing, what it's thinking, what it's perceiving, what decisions is it making. And all of that goes into the development of self-driving cars. It takes terabytes and terabytes of data to capture even one car's performance for a day, for example. And so it has to be captured and analyzed. And that's the other half of technology workflows is the analysis is typically done on large data sets with lots of people accessing them. I think we have a customer that has a I don't want to get this wrong, but I think it was over 200 terabytes data set, but they had 5,000 people who needed to access it simultaneously.
So the performance is not just going to one person.
No.
Collaboration spread out on a geographical basis across the world.
That's right.
Is another big aspect.
Exactly.
Of it.
Exactly.
So I think we have a question from the audience there. So.
Yeah.
Yes, we have a question.
So it says, you showed a tape archive as part of a solution with a 30-year life. What's the relative life of other storage, flash, HDD, DVD, etc.? So flash is still probably the shortest lifespan of a storage type. It's getting a lot better, and it's getting better by the year. It's measured in terms of drive writes per day. So if you have a 4 terabyte flash device and it's rated for 10 drive writes a day, it means that it can withstand 10 4 terabyte writes every day for 3 years. Okay. Right? So its expected lifespan is about 3 years. Right? I don't think anybody's going to use it that way, that much. And your mileage, as with anything, your mileage is going to vary. You'll probably use it until you lose it, and let's hope you have your data backed up somewhere else or protected somehow. So that's one of the things. Disk drives, I think disk drives can have a anywhere from a 2 to 5 year lifespan. Sometimes you'll get one that gives up a little early. Some go a little longer. I think the driver with disk drives is actually more the march of technology, where you're going to want to get to that next level because it gives you more capacity for the dollar and better performance. So typically disk drive refresh is a little bit shorter than their lifespan because of the technology. And to be honest with you, I don't know the data on DVD lifespan. I've heard rumors that it's 20 years or 30 years before they start to break down. But
in the structure that you were showing, it didn't really have optical as one of the big sections anymore. And a few years back, that was a big archive area. Is that still a strong area that's being used by companies?
Optical used to have the benefit of being fast and removable, right? And now we have on the high end is flash, and on the low end is tape, and they're both fast and they're both removable, just in different ways. So for long-term preservation, tape is great. You can write to it quickly. You can get back stuff fast. You can take it out and you can put it on the shelf. With flash, especially flash cards, like for cameras, it's perfect, right? Mm-hmm. Because you've got a portable medium. You can slot in a new one in seconds. You can keep shooting. So the popularity of those mediums. Also cost-wise, optical was always pretty expensive for what it did. So I think that we've seen an era where the technologies have gone beyond what optical is capable of, and now we've moved into memory-based.
So the flash solutions have kind of replaced what was going on with the optical as being that next tier between.
Right. It's still a good delivery mechanism for physical distribution of content. Everybody's got a red box out in their neighborhood somewhere, and it's got a bunch of DVDs in it. But even that is now under pressure from online services because of formats that have gotten small enough and look good enough at compressed rates to be able to be delivered over the internet that people can have at their home. So that was driving that change.
So in that media space, dealing with the physical media, gaming is now trying to figure out this transition between download only or physical media at the same time that they're upping the resolution.
Yeah.
And it's becoming a problem because if you need to download a 20 gigabyte game, that's not an immediate play. That's
And that's a trade-off that game developers and game players will continue to make. I think we're also seeing that in the world of VR, right? Some VR, the quality is so high that the author wants you to download it to see it at full quality. And in other cases, you can go to the Oculus website and you can stream VR content into your Samsung phone with a Gear VR headset for $99. And it's a pretty cost-effective deal, and you don't have to wait for anything. It's all streaming live. It's just a matter of quality for viewing experience, and what the author and the consumer is willing to trade off in terms of speed of access versus quality of image and experience.
so. In the slides, you were also talking about private cloud. So is that still mean I have to have an on-premise data center, or is there other forms of private cloud that are multi-tenant, private in the cloud?
There are organizations that can provide you with with essentially off-site ownership of some hardware that acts as a cloud system, but it's located in a co-location facility or somewhere, and it's managed for you. Okay. Private cloud tends to be thought of as something that you own, whether you position it in your facility or in a colo, but it's owned by you. Most customers who want private cloud want it for security, privacy, and control of the content, control of access to the content.
Yeah. That question came about because at the Oracle World that's going on this week, Larry Ellison gave his keynote on Sunday, and he mentioned that now they have availability that you could get their Exadata systems as a Oracle managed cloud on your facility inside your firewall.
That would be considered a private cloud that you're, I guess, renting?
Yeah, so it's so they called it an Oracle cloud because it's kind of not any one of those things. It's kind of like car sharing versus renting a car. You know, it's kind of in that gray area. At which point are you sharing versus renting? So
right.
So.
And at which point do they all get connected together and become sentient and take over?
Right. So I think we have a question from someone in the audience.
Yes.
Oh,
We
a
have
live
a
question?
question.
Yes, a live
We
question.
have a question.
So does the media storage solution require high-speed connection to the cloud?
Require, or you'd prefer to? I think you'd always like to have the fastest possible connection to the cloud that you can afford. Again, the trade-off is always cost for performance. So you could purchase a direct connect, what's called direct connect from Amazon, for example, and that would give you an opportunity to create a fast connection to a nearby Amazon host connection point. And from there, they go over high-speed fiber and get you into the cloud as quickly as possible. The connection from your facility to that location is also going to cost you some money. And depending on whether that's a private line or whether it's a shared line where you can get a gigabit of transfer or something, all I can tell you is that with media production, it'll never be fast enough, right? And Amazon has some interesting products that are trying to help with the onboarding of content, especially for the film industry. This is a product called Snowball, and where you can rent a device which comes out to the set and plugs in, and you plug in your Ethernet connection and you fill it up with data, and then Amazon comes and picks it up and takes it back to their facility and they load it into the cloud for you. And so, you know, these types of innovations and these types of new products and services are a way to try to mitigate that bandwidth issue, because with media, you know, we're not storing database transactions. We're not storing PDFs of people's contracts and insurance contracts and those kinds of things. These are multi-gigabyte, if not multi-terabyte files that take days to move around over standard infrastructure. So anything anyone can do to make that faster is going to be welcome. but at what cost?
Okay, thank you.
So, in that same mode, you were showing on that how much data is recorded for 1 hour. As we move to that 8K example, where it was over 7 terabytes an hour,
Yeah.
are there localized storage solutions? Because that's obviously not going into SD cards on the back of the camera. And
No, and frankly, it's not going to be very frequent that anybody works in uncompressed 8K, right? Even 4K. Most of the cameras have compressed formats, and they make it possible to record data onto large SD cards, even in a good quality 4K. I've started to see some, and we know of some of our partners that create small portable primary storage systems with maybe 12 or 16 drives in them, and they're rated to fit inside an overhead compartment in a plane and not weigh and weigh the appropriate amount to do that. So you're starting to see portable versions of primary storage that can do that sort of work, which is kind of interesting.
So,
But you're gonna, that level of work. Keep in mind, the thing that's driving the adoption of 4K is not the delivery of 4K in people's homes. It's the desire of content producers to capture the best possible pixels at the time they have the chance, because they only get one chance. So they want to get the best pixels they can get at that time, the greatest dynamic range with HDR, the greatest frame rate with HFR, the high frame rate. So they're going to capture the best they can, and then they'll edit down and compress and deliver long before the universal adoption of 4K in people's homes happens. So there's two different drivers. Most of the 4K production is being driven by content producers, not consumers.
So another question that came in on the internet was, these media solutions and long-term archives, there's a challenge with having large archives. And that is, are they going to be compatible with the new GDPR privacy and security rules that are coming up in the EU and then will probably be followed here? What we're seeing is a lot of questions from people in the financial industry and the medical industry, which have a huge image database issue, that are looking at these media archive solutions.
Right.
And they're very concerned about these new privacy rules that are coming into place.
Right.
So is the structure that you have, is the security and the privacy part of that, or does that sit on top?
They can be. It depends on the infrastructure. And in both the case of tape and disk, there are devices that support built-in encryption, and so that data can be encrypted. Obviously, the United States government uses technology as well as anyone, and they require this kind of level of privacy and this level of encryption to be built in. Also, the data itself can be encrypted regardless of the type of storage. And when you look at tape, and we're talking about longevity of tape, the LTO format has been around for many, many years. We're now in LTO 7, and about every 3 or 4 years, a new generation comes along, and capacity gets higher, and people are moving. But that also means that we get an opportunity to support new functions and new capabilities. And encryption has always been high on the list of issues for long-term preservation of data.
Okay. In that same area of privacy and security, there's still a lot of concerns about being in the cloud, and especially on this transport. So it sounds like you were mentioning, with this Amazon box that you could plug into and then they load it in place. That's like really advanced sneaker net that you're basically.
It's the biggest. It's about this big. It's a giant sneaker. Right.
So in that technology, you're still highly dependent on physical access, physical control of the devices.
Yeah. So what you want to do if you're concerned about the security and privacy of your data, is make sure that when you put data into the cloud, that you have something called client-side encryption. So this allows you to create the keys and manage the keys and hold the keys for your data. And any cloud provider who is storing your content can't get to it. Even though they're storing it, they have no way to access it whatsoever. You're the only person who has the encryption keys. And that's different than server-side encryption, which is a service that cloud providers will provide to you. Amazon does. When your data lands, it is encrypted and it's given a key, and the key is stored with your data and it's randomized and it's refreshed on a periodic basis, usually every day or 7 days, something like that. And then, so the key is held by the content storage provider. A better solution when you're looking for cloud providers for privacy purposes is client-side encryption. And in our case, we support both. Amazon supports both. I think Google, everyone is going to support both of those depending on what your requirements are.
In this solution, you talked about archive and vaulting.
Mm-hmm.
Are those fundamentally different from backup?
Yes. Yeah, that's a good question. So a lot of people get a little bit muddled about the difference between backup and archive.
Yeah.
And archive and vault are related. A backup is the process of keeping your work on a daily basis, a small amount of data that's being worked on, and then refreshing that every day to make sure you have today's copy, right? That's backing up. And it works good in IT organizations. It works good for small data sets. It can work in media production workflows if they're small, or if your projects are, like someone who's doing commercial spot production, backup is fine. You can back up your work, but it's considered to be you're writing over the backups with the latest backup. Mm-hmm. And it's a short-term recovery solution. Archive is for content that you intend to keep for a long time and reuse and remonetize and have it be an active part of your production, but not taking up active, expensive primary storage space. So you're going to move that into archive, and the availability, the access of that content depends on what kind of archive you're using. If you're archiving to object storage, it's instantly accessible. You can get it back on a moment's notice. If you're archiving to tape, 5 seconds to load a tape, you've got it. You're archiving to cloud, may take you an hour to pull down a big file. But it's content that you intend to access at some point in the future. It's arm's length stuff. And then vaulting is, with tape, for example, is the act of taking that tape out of the robotic equipment and putting it on a shelf. But it's important with vaulting that your storage system keeps track of that data also, automatically. So you don't want to have to keep track of that manually. So vaulting is a process that does that. In the cloud world, vaulting tends to be a lower cost tier of storage, but that has a higher retrieval cost. So you're trading off storage per month, cost per month, for how much you're willing to pay to get it back.
So you had mentioned that some of the tape systems actually check the integrity of the tape. Mm-hmm. So if you have, and that's in the vaulting environment, in the archive.
At least in our case, it's on any tape system.
Okay.
We provide a function called extended data life management, which is we do CRC checks on the tapes every time they're touched, and if they're not touched for a while, we go and touch them. I think of it as like riddling the bottles in the winery. You go along and you twist every bottle just to make sure it gets agitated a little bit, and they get to see, does that data test out? Does the CRC match and everything's the way it should be? A tape can be damaged by a gamma ray, mm-hmm. right? And you can lose a bit. It's called bit rot, and it happens. So what we want to do is catch that while we have another copy of the data. Remember, the whole point of this distributed storage system is to have copies of data in multiple locations.
Right.
And so we have another copy, we go recover that, we rewrite the data to the tape, and it lives on. So that's an important aspect of data resiliency, is how you can recover from those kinds of errors and not have it be invisible.
So in that scenario, this duplication of the data, does that remove the need to quote unquote back up the archives and the vaulted data?
Essentially, that's what you're doing. Yeah.
Okay.
You would program your workflow to say, all right, well, I'm going to put two copies of this on tape, and so it will put it in 2 different locations. And I've got the dailies in the cloud, but let's go ahead and put the finished work in the cloud also. And frankly, for the cost of storage these days, it's much better to throw an extra copy out somewhere than it is to try to save 4 terabytes of storage on a production, right? And that client comes in, and all of a sudden, you don't get the data that you expected because you only had 1 copy. Mm-hmm. That's the day you're going to be looking for a different business to be in.
So, one of the other issues with storage, and this was something that still is in discussion about Flash, is you were mentioning the content producers want to get the best data, the highest pixels, highest. What is the reliability and bit error rate for capturing in these systems off this one-time data? The ingest is very much a one-time thing. So there was an issue with the early Flash products going through that they wouldn't record them correctly.
Yeah.
And this, a lot of those issues have been resolved both between the interfaces, the Flash products themselves for going through. In this structure, is there any major issues for having the same data in multiple places and making sure it actually got there? And kind of how does this ingest work with coming in and knowing that the data is actually valid?
Yeah, I see what you're saying. So in high performance storage systems, what will happen is when you copy a file from one place to another, even if it's from a flash device to a disk drive, you're not moving that data in real time. In other words, you're not saying, I've got these bits, I'm going to scrub them off here and I'm going to write them over here, and I hope I don't forget on the way. You're going to make a copy and you're going to confirm that that copy matches the original source, and it only then, if you decide at a later date that you want to remove that original source, then at that point you remove it, and then this file would be your only one. In the case of a hierarchical storage system or a storage environment where you're creating multiple tiers, you can set up policies that would say, all right, here's my file on primary storage. I want to create a copy on tape and a copy on object storage, but then I'll keep it on primary storage just in case I need it maybe in a couple of days. But your policy might be, after 30 days of not being touched, go ahead and remove the original file. We've got those other copies out there, but leave a pointer on the primary storage so my applications and my users can find it if they ever want to use it. So then they just click on the file with the archive bit set, and it goes and gets the fastest copy available. So that's how this
so the policies are being
it's
set
a policy-based file movement and file protection environment.
So this was a major point of discussion. We were covering the drone show, and a lot of the camera systems involved are using streaming. And one of the biggest complaints was frame drop from these systems because they're trying to use localized Wi-Fi, and they didn't quite comprehend that Wi-Fi has dead spots in it in open environments.
Right.
So as a result, the content never gets there, and they've been primarily blaming the storage architectures, not the transport technology.
Right. And those kinds of problems in the past, when those problems have arisen, where delivery of a file was based on latency, or gaps in data, it was solved by having local cache. Right, you'd cache the content as it comes in so that you could go get it when eventually when you could.
Right.
So if you lost connectivity, it's still there in cache. It's just waiting for you to regain access. Right. So those kinds of problems get solved. Drones are relatively new.
Right.
Most people are having too much fun with them to worry about those kinds of things, unless they're in professional sports or somewhere like that. But it kind of goes with the territory.
The folks in agricultural and industrial, they haven't been complaining about that, but a lot of the consumer, prosumer, those products haven't resolved all those issues.
Right. Yeah, and it's interesting. We have a lot of customers who are corporate accounts, who they're producing video for the purpose of educating their employees, or for documenting work on site, or for certification of training for particular safety procedures and those kinds of things. And the reason they're doing that in-house now is because the cost of video has gotten so much lower. And in fact, I saw a corporate video that included aerial shots from a drone that would have cost tens of thousands of dollars to get just 5 years ago, to rent a helicopter and get a shot like that. But now it's great.
So Dave, we're just about out of time. So thank you very much.
Thank you so much. Really, it's been great.
And next month we're going to be doing our next talk with the head of SMPTE San Francisco, is going to be talking about the SMPTE Centennial event. So we hope you join us next month. Thank you very much.
Thanks.